Hello students, let's see one topic student, that is LCAO, formation of molecular orbital by linear combination of atomic orbital. So what is LCAO is student? Linear combination of atomic orbital, right? So what do you mean by this? According to wave mechanics, the atomic orbital can be expressed by the wave function, okay, psi. Atomic orbital can be represented by wave function. Keep in mind student, that is atomic orbital you are mentioning by wave function, which represent the amplitude of the electron, which represent the amplitude of electron wave, These are obtained from the solution from the Schrodinger wave equation. However, since it cannot be solved for any system containing more than the one electron, so molecular orbital which are one electron wave function for molecules are difficult to obtain directly from the solution of Schrodinger wave equation. Okay, so what is to overcome? Okay, to overcome from this problem, an approximate method known as linear combination of atomic orbital LCAO has been adopted. So what the point is student, they are saying that is if you are talking about the molecular orbital, so there will be more than one electron. For that type of system, what we are saying student, this is for that types of system what we are going to do, that is we are following the linear combination of atomic orbital. So let us apply this method to the homonuclear diatomic hydrogen molecule. Consider the hydrogen molecule consisting of the two atoms A and B. Each hydrogen atom in the ground state has one electron, one s orbital. The atomic orbital of these atoms may be represented by the wave function of the psi A and psi B. Right. Now, student, mathematically, the formation of molecular orbital may be described by the linear combination of atomic orbital that can take place by addition and by subtraction of wave function of individual orbitals as shown below. The psi molecular orbital is equal to psi A plus minus psi B, right? Therefore, the two homonuclear orbitals sigma and sigma stars are formed. First one, sigma is equal to psi A plus psi B, and sigma star is equal to psi A minus psi B. Okay, the molecular orbital sigma formed by the addition of atomic orbital is called the bonding molecular orbital, while the molecular orbital, that is sigma star, formed by the subtraction of atomic orbital is called anti-bonding molecular orbital as depicted in the figure. So how it is depicted in the figure? You see, anti-bonding orbitals higher energy than that of the atomic orbital, and bonding orbital have the lower energy than the atomic orbital. So here that is increasing order of energy, you can see, that is orbital is represented, that is psi A, this is psi B. So if you are there is orbital sigma is equal to psi A plus psi B, and sigma star is equal to psi A minus psi B. So this is the point. Now come to the here formation of the bonding sigma and anti-bonding sigma star molecular orbital by the linear combination of atomic orbital psi A and psi B centered on two atoms A and B respectively. So what is happening student? Qualitatively, the formation of molecular orbital can be understood in terms of the constructive or destructive interference of the electron wave of the combining atom in the formation of the bonding molecular orbital. The two electron wave of the bonding atoms reinforce each other due to the constructive interference, while in the formation of antibonding molecular orbital, the electron wave cancel each other due to the destructive interference. As a result, the electron density in the bonding molecular orbital located between the nuclei of the bonding atom, because of which the repulsion between the nuclei is very less, while in case of the anti-bonding molecular orbital, most of the electron density is located away from the space between the nuclei. In fact, there is a nodal plane on which the electron density is 0 between the nuclei, and hence the repulsion between the nuclei is high, right? Electron placed in the bonding molecular orbital tend to hold the nuclei together and stabilize molecules. Therefore, a bonding molecular orbital always possesses a lower energy than the other atomic orbital that have the combined to form it. In contrast to the electron placed in the anti-bonding molecular orbital, destabilizes the molecule. This is because the mutual repulsion of the electron in this orbital is more than that attractive between the electrons, the nuclei, which causes the net increase in the energy. It may be noted that the energy of the anti-bonding orbitals is raised above the energy of the parent atomic orbitals that have combined, and the energy of the bonding orbital has been lower than the parent atom. The total energy of two molecular orbital, however, remains the same as that of the two original atomic orbital, right? Condition for the combination of atomic orbital that we will discuss in the later part of the video. So this is what the point is, student. They are saying that is the point is that is two type of molecular orbital formed. Okay, so what is named of it, student? So that is bonding molecular orbital, bonding molecular orbital, and another is what is there, student? Anti-bonding. This is what is anti-bonding molecular orbital, right? Now if you talk about bonding molecular orbital, they are saying that is this stabilizes, stabilizes the molecule, okay, molecule. And what the other point they are saying, anti-bonding molecular, that is destabilizes, destabilizes, okay, destabilizes the what, student? That is molecule, destabilizes the molecule. This is the second point. Now here is what is that is attraction is high. In this case, what, student? This is attraction is what, student? Attraction is high, and here is attraction is low. This is the attraction is what, student? Attraction is low. Okay, so that point we have to keep in mind while the solving the we have to, when we are applying the the concept of the LCAO. Like if you are doing the hydrogen, student, that is when you are talking about hydrogen, so that is two atomic orbital are there, right? Two atomic orbital. So and here is one electron, here is one electron. Now when you are forming the molecular orbital, there will be the two molecular orbital forming, okay, two molecular orbital. When the two molecular orbitals are forming, student, you can see that is one is called sigma, okay, sigma. This is the molecular orbital, sigma. This will be the molecular orbital, and sigma star, that is anti-bonding molecular orbital, and this is the bonding molecular orbital, bonding molecular orbital, that is ABMO and BMO, right? Now you check the energy, student, which is having, this is having the least energy, na? So least energy means stable, okay, stable, stabilizes, okay, and here is more energy means what, student? Destabilizes. This is the destabilizer, okay, destabilizes. So this is what about the concept behind the LCAO method, student. Thank you so much for watching, friend. If you find this video helpful, please do like and subscribe the channel, and don't forget to comment, students.